So let us draw the ray diagram and locate the image formation by the lens. Image formation by the lens. It is first it is convex lens. So convex lens is the converging lens. Convex lens is a converging lens. So by following the rules for the ray diagram, we have to draw the ray diagram and locate the image. So the object is kept at infinity. So let me draw a diagram object at infinity. So the object is at infinity. I'm drawing a ray diagram. The light from the object parallel to the principal axis, it fall on the lens and it will be focused right hand side. So one more light, because the intersection of two light, the point of intersection at which the image is formed. So the parallel light falls on the lens and it gets converged at the point F2. So there will be formation of image at the formation of image at F. Image will be formed at F. The image will be real, inverted, diminished, point-sized image will be formed at F2. Actually, whatever the F written in the right hand side, it will be F2 to F2. The left hand side, it will be F1 to F1. So the image will be formed at F2, real, inverted, diminished, point-sized image. So when we keep the object beyond 2F, so beyond 2F, I'm drawing a object beyond 2F. The parallel light fall from the object and it pass through the focus after refraction. So one more light, it passes from the object, pass through the optic center O. The point of intersection at which the image is formed. The image, it will be real, inverted, diminished. It will be formed between 2F2 and F2. So it will be formed between 2F2 and F2. The nature of the image, it will be real, inverted and diminished. When we keep the object at 2F1, 2F1, the object is kept at 2F1. The object is kept 2F1. The parallel light ray from the object, it falls here. And after the refraction, it will be passing through the F. And one more light ray, it come from the object passing through the O. The point of intersection, there will be formation of image. The formation of image at 2F2. The image will be formed at 2F2. The nature of the image, it will be real, inverted and same size of the object. If we keep the object between 2F and F, 2F and F, that is 2F1 and F1. So I am keeping the object between the parallel light rays, the light from the object parallel to the principal axis, and it will be passing through the same way the second light ray, it will be passing through the optic center. It will be intersecting at one point. It will be the point of intersection at which there will be formation of image. So the formation of image, it will be beyond 2f2. The nature of the image, it will be real, inverted and enlarged image is formed. When the object is at f1, at f, the object is at f, correctly at f, we are keeping the objects, the parallel line, the light from the object parallel to the principal axis, and it will be after refraction, it will be passing through the f, and one more light ray, it passes through the O, but they never intersect. So the image will be at infinity. The nature of the image, it will be real, inverted and highly enlarged. So big as the image is formed at infinity, it will be highly enlarged image. When we keep the object between F and O, F and O, we are keeping the object between F and O, the parallel light rays passed through the F, and one more light ray, it is passing through the, it never intersect, so we produce the light, and this light refracted light ray we are producing, and they join at one point at which there will be formation of image. So it will be beyond 2f1. So there will be a virtual, the image will be formed beyond 2f. The image will be virtual, erect and enlarged. Enlarged image, it will be at the same side of the object. So the object is this side, the same side, you are getting a virtual, erect, very enlarged image. So coming to the concave lens. Concave lens is a diverging lens. So when we keep the object at infinity, when we keep the object at infinity, I'm keeping the object at infinity, the light ray parallel to the principal axis, and this concave lens is a diverging lens, so the light get diverted like this. When we produce the diverted light, it pass through the f, so the image will be formed at f. The image, it will be formed at f. The nature of the image, it will be virtual, erect, virtual, erect, highly diminished, that is point sized, highly diminished, point sized image, it will be formed at f. When we keep the object between infinity and O. So when we keep the object between infinity and O, the same way the parallel light from the object, it is parallel to principal axis and it gets diverted. When we produce the diverted rays, the image will be formed between F and O. F and O. The image will be virtual, erect, diminished. When we bring the object closer to the lens, the image size also, it will be increasing like this. The image size, it will be going on increasing when we bring the object closer to the lens. So this is the way the image will be produced. It will be produced between F and O. So by drawing, whenever you are drawing a ray diagram and locate the image, what you have to do, you have to take a measurement and draw F and 2F. F, it should be 4 centimeter. If it is 4 centimeter, 2F, it should be 8 centimeter. And you have to draw the lines with the ruler. And when you are drawing with the scale or ruler, you are able to locate the image easily. So this is the way to draw the ray diagram and locate the image.